everybody, welcome back. This is 6.51. We're skipping graphing for now. We'll come back to that towards the end of the year and review that. But this is on properties of logarithms. And I discussed earlier, the properties of logarithms have to do greatly with our exponent properties, okay? So we're going to look at just kind of proving these exponent properties, logarithm properties first. So first of all, if we let x equals log base b of m and y equals log base b of n, then if we put this in exponent form, b to the x power equals m and b to the y power equals n. So we have these two expressions here, equations. We're going to multiply these expressions. So we're going to, if we, imagine if we were to write it as right here, b, grab my pen here. We write this as b to the y equals n, and we're going to multiply top and bottom. So b to the x times b to the y equals m times n. So we're going to just multiply that together, okay? Then we're going to use our property of exponents right here. So remember, if we have base to a power times base to a power, we add those powers. So we end up with b to the x plus y times m times n, okay? Now we're going to take this expression and write it as a logarithm because we have exponents up here, right? So we're going to have log base b of m times n equals our exponent, x plus y, okay? Well, up here, x equals our logarithm log base b of m and y equals log base b of n. And so therefore we have, we're going to substitute that back in for x and y. So we have this log base b of m plus log base b of n equals log base b of m times n. And this is a logarithm property, okay? Because that's what happens when we multiply bases, we add our exponents, and that's what's happening here. When we multiply these bases, these are basically base of the argument, we're going to add the logarithms, okay? So we add log base b plus log base n. So that's a logarithm property, okay? So let's take a look at the quotient property as well. So what happens when we have, if we have x equals log base b and m equals log, x equals log base b of m and y equals log base b of n, then we're going to use a quotient property. So let's divide them this time. Okay, so b to the x divided by b to the y equals m divided by n. Well, that's going to give us, we're going to subtract our exponents, x minus y. Okay, because when we divide, we subtract our exponents. That equals m over n. And again, we're going to write it in logarithm form. So log base b of m over n equals our exponent x minus y. Okay. Then we're going to resubstitute back in our x and y with our logarithms. So log base b of m minus log base b of n equals log base b of m divided by n. And this becomes a log property. Okay, we're going to use these to help solve equations and write and rewrite equations. Okay? So what about the power property? How does that relate? We're going to kind of come to that proof later, but our power property here, here is our multiplication product property. Okay, and you can go back and forth. And going this way is called expanding, and coming back is going this way is expanding, going back. We'll talk about that in just a second. So here's my exponent rules. If I have a base to the power times base to the power, I add my powers, and that's the same thing we do with the logarithms. If we divide, okay, we subtract our exponents. It's the same thing with my logarithms. And on my exponent, just kind of look at this pattern here. If I have a to the m raised to the n power, it's a to the m times n, right? Well, the logarithm, if I have log of m raised to the n power, we're going to multiply them by taking the n exponent out in front and going n times log of m. Okay, so that's how I end up multiplying it, n times log of n. Okay, so those are my logarithm rules. All right, so you need to know these. Okay, so if I go this way over here, right, log base b of m times n equals log base m plus log base b of n. This is called expanding, going this way. Going this way is condensing or compressing or writing as a single logarithm. And I might add that as, writing as a single logarithm over here. Single logarithm, okay? So you might want to, put that to your memory. These should be in your notes somewhere. Reference them quite often until you have them in memory. You're going to use them a lot. If you're going into pre-calculus next year, you'll use them all of the time. You'll use them all the time this year, okay? Okay, so let's practice it, okay? So we have a log base 5 of a squared times b to the 7th. How can I use log properties, the properties of logarithms to expand this expression? So we want it to get big, we want more logs, okay? basically. Well, this is product property, right? So it's a squared times b to the 7th. So we're going to expand that to log base 5 of a squared plus log base 5 of b to the 7th. Okay, so that's my product property, is the addition. So remember, when I multiply exponents, I add them together. Okay, and now I have this product property, right? So now I have this, or excuse me, exponent property right here, power property. That means that that's going to come out front. My power is going to come out front. It's not simplified if I have any exponents. So this will be 2 log base 5 of a plus 7 log base 5 of b. And that is expanded. Okay, no, it's not fully expanded if I have any exponents. Okay, so just keep in mind of that. Look at this little box over here. Expanding logarithm expressions requires the use of a variety of properties. Look at the whole expression first to determine the sequence of properties that will be used. Okay, so that's kind of important. So natural log of 25 over 3. So first of all, I'm going to rewrite the numerator as a power. So I'm going to write natural log of 5 squared over 3. Okay, then I'll write that as natural log of 5 squared. And then since it's a division, it's going to be subtract natural log of 3. Okay, then I'm going to put my power out here. So 2 natural log of 5 minus natural log of 3. Okay, now we just expanded that. We're not calculating it. It didn't say ask us to evaluate it. If it asked us to evaluate it, I could actually calculate 2 times the natural log of 5 minus the natural log of 3. Okay, so here, you guys go ahead and try this. Maybe pause this video and see how you do with this. Okay, so first of all, I'm going to look at this, and I can't really separate this top without separating the bottom first, right? So I'm going to use my division property first, my quotient property. So log base 7 of r cubed t to the 4th minus log base 7 of v. Okay, so I'm going to subtract those first. Now I can deal with this multiplication. All right, so I'm going to have log base 7 of r cubed plus log base 7 of t to the 4th minus log base 7 of v. Now I have to deal with these exponents, right? Move them out in front, move them out in front. So I have 3 log base 7 of r plus 4 log base 7 of t minus log base 7 of v. So these can get quite long sometimes. Okay, and that is fully expanded. Okay, so now you might want to try this one again. Go ahead and pause the video and see how you do with this one. Okay, so again, I'm going to use division. Log base 4, use my quotient property of 4x to the 6th minus log base 4 of y to the 8th. Y to the 8th. Now what I'm going to do is I have two things going on here, right? I need to separate this product first, and I have this power over here that I need to go ahead and put out in front. Okay, so I'm going to go ahead and separate this log base 4 of 4 times, or excuse me, plus, to separate that, log base 4 of x to the 6th minus, I'm going to move that out front, 8 log base 4 of y. Okay, well, if you remember our properties, log base 4 of the same argument, that becomes just 1, right? So 1 plus log base 4 of x to the 6th, or the 6 should go out in front, excuse me. So the 6 log base 4 of the x minus 8 log base 4 of y. Okay, and we're done. All right, so that's expanding our expressions. Now we're going to, I'm going to skip this one. Now we're going to take a look at condensing. So writing with a single logarithm. Okay, so we're going to kind of get going backwards. So remember how the last thing we did was exponents, putting them out in front. Well, that's going to be the first thing we do now. Okay, and so we're going to take all of these powers out here in front. We're going to put them back up where they belong. Okay, so we're going to take our log base 4 of m to the 4th power plus log base 4 of n to the 3rd power minus log base 4 of p. Okay, and then I'm going to kind of work left to right. So I'm going to go ahead and multiply, use my product property here. the log base 4 of m times n, m to the 4th times n cubed, minus log base 4 of p. Okay? Now, I can take this guy and put this underneath and use my division, my quotient property. So log base 4 of m to the 4th n cubed over p. Keep in mind, a lot of people like to write this as like log base 4 m 4th n cubed divided by another log. Don't do that. Okay, it's a single logarithm. Remember, we're writing it as a single logarithm. There's just one log. Okay, so you shouldn't have two logs written when you're finished. Only one log. Okay, so keep that in mind. Okay, so what's this expression written as a single logarithm? So again, let's do our power properties first to make sure we get that taken care of. So this 3 is going to come up here. This 2 is going to come up here. Okay, so I have my natural log of 2 cubed minus natural log of 5 squared. Okay, so this is going to be actually, let's go ahead and go natural log of 2 cubed minus 5 squared, and we can actually write that as natural log as 8 actually over 25. Okay, so 8 over 25. And you're all done. Single logarithm. Okay, remember that. Single logarithm, not 2. Okay. All right. So you guys maybe go ahead and pause this video and do this one and see how you do. Okay. So this power is going to go up here first. Power is going to go up here first. We have log base 2 of c to the 5th power minus log base 2 of n to the 7th power. Now I can use my quotient property because that's subtraction. So we're going to go log base 2 of c to the 5th divided by n to the 7th. And we are all condensed. Okay. One more. Okay. So this is going to be natural log of 7 squared plus natural log of 2. This is multiplication here. So we're going to go natural log of 7 squared. Oops, I have 2. Sorry about that. Times natural log of 2. That's going to be natural log of 49 times 2, which is natural log of 98. And we are all condensed. Okay? So that's it. So that's this requires just practice and getting used to it. Okay? They're kind of wonky at first to get used to, but once you get practicing with it, you'll memorize them and it'll be just kind of like secondhand. Okay? You guys have an assignment. It's a worksheet in Google Classroom, and then I will see you all in school. Take care. Bye-bye.